Hello everyone, I hope you are all having an awesome time here at PyLadies Con. I'm excited to introduce our next speaker, Milena Miernik, an AI developer who combines her background in linguistics and education to help her learn a new language after moving to Sweden. Put your hands together for Milena presenting building a self-hosted AI Swedish tutor, a love child of teaching and tech. Take it away.
Hello everyone, my name is Milena Miernik and I want to start by saying how happy I am to be here and to have a chance to talk to you about this project. So my talk is called Building a Self-Hosted AI Swedish Tutor, but it's not just about the tech, it's a love child between teaching and tech. So if you're into AI, building sustainable projects, or exploring how AI can stretch beyond pure tech, you will hopefully find something here for you. So the origin story of the project. My background is actually in linguistics. I studied English philology and sociolinguistics, and I spent several years teaching English as a second language. However, a few years ago, I moved to Sweden and switched careers into AI development, and I got absolutely hooked. So combining my passion for language with AI gave me a really unique perspective. So now I can nerd over both grammar and neural networks. And that's why we're here. So I started to learn Swedish, but I was becoming more and more disappointed with the lack of good study materials for higher levels. So there's a ton of good materials for beginners, but not so much for advanced learners. So one day in my advanced Swedish class, after being forced to analyze the same 19th century short story for the fourth time, I've decided I've had enough. I slammed the Zoom door behind me and decided to build my own Swedish tutor. And that's how this project began. So here we are. Let's talk a little bit about the vision I had, both from the language learning and the technical side. So I knew it had to be fun and personalized. If it's not enjoyable, I'm just not going to use it. I knew I wanted to focus on vocabulary while at the same time getting a nuanced and interactive feedback. I didn't just want to know if it's right or wrong, I also wanted to have an explanation. And this would be a challenge, I knew from the get-go, because we have to remember that whatever the model sees is tokenized first. The models never see the words or sentences. And even for the multi-language models, they are trained predominantly on the English language data. So there was a question of how well will they perform with Swedish token patterns and morphology. So that was actually a very interesting area to explore. How are the tokens mapped inside different models' neural networks? On the technical side, I wanted to self-host the models. I don't want to bind the core functionality of my app to an external service. And I ran it on my NVIDIA GeForce 4070, which is a good gaming card, but it's not optimized for generative AI. So with 12 gigabytes of VRAM, I can reasonably run models of up to 10 billion parameters, which is plenty for the kind of build I had in mind with agentic AI and modular design. So I kept coming back to three guiding principles. I wanted to be personalized, decentralized, and sustainable. So let's have a look at what it looks like. The whole concept is based around fetching an interesting article from Wikipedia, extracting vocabulary appropriate for my level, and then having a discussion about this article. So these are AI-generated suggestions for topics. And these are the actual articles on Wikipedia available on this topic. So let's pick this one, for example. And what's happening right now in the background is that my backend is already working on this article and processing it while I have time to read it. And this is a smarter way of working with AI because I don't need the answers instantaneously. It can take a few seconds to process all of the sentences while I sit and read the article. So now it's been a minute, my flashcards are ready. I can read all the words that were extracted, their explanations and how to use it. All of them are around B2 and C1 level. Here I can have a conversation about this article, and the prompt, I was very specific in my prompt. I am expecting the best conversation in my life about this article. So I wanted to avoid generic questions here, just having a really deep conversation about this topic. And over here I can see the feedback on everything I have said. So whether it was correct or not and how I can express myself better. So now it's time to talk a little bit about the tech stack I used in the project and prepare for my serenade to Ulama. So Ulama is awesome, and I could give a whole presentation solely about why I love it. But to be brief, it's mostly because it's so easy to use and so smart about hardware. So you just download the client, install it, and pick a model from their hub, and Bob's your uncle. You can run inference on it. So once installed, you can even chat with the model right from the terminal. But the real power is from using the local API. As you can see, it lives on your local host on port 11434. And it exposes a number of endpoints. So for example, this one is for running inference on the model. But I mean, you're not just going to curl your model all the time, and that's where LangChain comes in. So LangChain is a collection of model wrappers. So it contains tools for prompting, chaining, tool calling, and everything you might need or want when working with LLMs. So here is a simplified example of how I used it for tool calling. So here, as you can see, I am defining a tool. This is a call to an SQL database that I set up. I create an instance of my language model, and I bind the tool to it. So this model will have access to these tools. And as you can see, this is a list. So we can equip this model with multiple tools. So here in the system prompt, I can specify which tools this model has access to and how to use them. And that's it. LangGraph is what I used to glue all the parts together. The whole project consists of multiple agents, and that's how they communicate with each other. So here you can see the flashcard extraction workflow. So instead of writing one big linear script, I can define each step as a node. So each node contains its own logic, and the edges define in what order the nodes will be executed. So what's powerful here is that LangGraph keeps the state between the steps, so I can loop and control when to continue and when to stop. And here you can see it also prints an ASCII version of the workflow. So each node updates the state of the workflow. So you can think of the state as a shared memory that keeps track of what's happening between steps. So here you can see the declaration of that shared state. So this is my pipeline state, and these are all the fields that I want to have in it. And if we look closer at what this node does, so this is this node. So it takes in the state, it does its logic, and it returns an updated field in the shared state. And LangGraph will automatically merge those updates so that all of the other nodes will have access to this updated data. As I've mentioned, I'm using agentic AI in a very modular design, so in principle I could have different models performing each different task in the whole application. So I wanted to show you how did I choose the model to perform the most difficult task of giving me a nuanced feedback on my Swedish. So the first step was to prepare the data. So I built a data set with utterances with some mistakes in them. And then for each utterance, I prepared a ground truth. So what kind of correction am I expecting from the model? And then I picked models to run the tests on. So I just looped through prompts and models, and I recorded each output and some metrics. A good metric to collect is latency. Even though we're not looking for the fastest model, it's good to have an idea of how long we will need to wait for an answer. A pro tip is to clear the cache between different runs, because Ulama caches the answer. So if you run the same prompt twice, you will get a cached answer. And run multiple loops to really see consistency in the models, because just because a model behaves in a certain way once, you have no guarantee that it will do so consistently. And then comes the evaluation. And since you already have the ground truth for what you're expecting out of an utterance, you will know if the model is performing well or not. And here I also used AI judges to help me evaluate all of the other models. So they set scores and comments on how close the output of that particular model is to my ground truth. But here a very important point is to still have human in the loop, because the AI judges will only be as good as my own ground truth. So it's very important to have an oversight, not just trust the numbers that we see. And to give you an idea of what it looked like in practice, so this is the JSON that came out of some of the tests. So I have IDs for both the system prompts and the human prompts to keep track of what was fed into the model. The sentence to correct was this, and this is the ground truth. So what kind of answers am I expecting? What kind of corrections are acceptable? This is which model was tested. This is saving the actual response from this model. The latency was really good. It was under 1 second. And here are the judges' verdicts. So all in all, Llama 3.18b performed reasonably well with the average score of 8.0. So to sum up, why is agentic AI so powerful? Is because it is so scalable. So as opposed to just chatting to one model, having one model, it's so easy to add extra logic, extra agents to the whole application. It's very transparent. Instead of having one black box that we get responses from, each step is inspectable, and we can see how it arrives to its answers. It's autonomous, so agents can decide what to do, if they need to use a tool or not, what will be the next step. And it's sustainable. By using a collaboration of smaller models, we are avoiding binding us to running these huge data center class models. And to sum up the whole project, the lessons learned are that 3 models in a trench coat can pass for a big, powerful model for a fraction of the cost and environmental footprint. As well as sustainability isn't just about the energy, it's also understanding your workflow and being able to maintain it over time. And when it comes to next steps in the project, I have way too many ideas, so for sure, there's plenty of next steps to take. So that's all in my presentation. I hope you enjoyed it, and I hope that you reach out and we continue the conversation from here on. Bye-bye.
Thank you for sharing your personal journey and expertise, Milena. Your presentation was really insightful for anyone curious about multilingual LLMs, agentic reasoning, or sustainable AI development. I hope you all enjoyed that talk. I know I did. Thank you all for supporting the PyLadies community. We have more exciting talks ahead.